Question number one, it says, for each of the following functions, use the first derivative test. In case you don't know what the first derivative test, we talked about it yesterday. And all that means is we're checking where the first derivative changes signs to find local extrema. Local extrema means max and mins, my local max and mins. Identify any absolute extremes if there are any. Oh, hold on. That sound you hear is the announcement. So it's about to make an announcement. Yes. Okay. I guess there was no announcement. So yeah, that's what first derivative test means. So what does first derivative test mean, Viacana? When what sign changes? Oh, the derivative sign. So here we go. Without graphing, relax, miss. I'm just trying to make you better. Without graphing, take the derivative. The derivative of x cubed minus 12x minus 5 is just 3x squared minus 12. I'm going to factor out a 3. So you're going to have x squared minus 4. And I'm going to set that equal to 0 to get critical numbers. So notice that's the difference of squares. Hopefully I didn't mess up. X minus 2, x plus 2. No, you don't have to do that. You could have just done square root of 4 plus or minus 2. But I like to show that. So then from there, you get these two values. And then I like to, by the way, this is not enough to justify, but for now, because we're not teaching to the test, for now, here's my number line. I label this f prime. And all I'm going to do is put values in there. All I care about is the sign, positive or negative. So if I choose negative 10, so look, negative 10 squared is 100. 100 minus 4 is positive, so positive. If I choose a 0, so 0 minus 4 is negative. Negative times a positive is a negative, so negative. And if I choose a number to the right of 2, I get a positive. If you're wondering where I'm inserting the numbers to, I'm inserting them to the derivative because I want to know if the derivative is positive or the derivative is negative. So I do have some sign changes. I have a sign change here at negative 2. So it goes from positive to negative. Remember, you read a graph left to right. Positive to negative. So that's going to be a what? A max. Perfect. And then this one here is changing from negative to positive. So that is a min. And there it is. If they want to know, are these absolute? Nope, they are just local. How do I know they're not absolute? This is x cubed, guys. So it's going to look something like, I don't know, it has like a dip, something like that. So there at negative 2 is a max. Here is a positive 2 is a min. So those are local. It goes up forever. It goes down forever. So there's no absolute. Does all that make sense, guys? Perfect. Let's go to this next one. This one's a little bit tougher because I have an exponential in there, but it's still the same logic. Let me take a sip of my coffee really quick. Oh, I'm pretty much done. Yeah, maybe. I'll let you know if I order one and let me know what you want. All right, so here we go. What rule do I got to use to take the derivative of this? Product. So g prime of x equals first. I know some of you guys don't like this. Go ahead and do it your route with the e to the x times the root of the second plus the second times the root of the first. If you have it reversed, it's no big deal. You're going to get the same answer because there's a plus in the middle. So now I look at this and I'm like, Chavez, I don't know how I'm going to get critical numbers from there. I don't have a calculator. Yes, relax. Here's a product. Here's another product. What can I factor out of these products? E to the x. When you factor out the e to the x, you're going to get x squared minus 3 plus 2x. Let's rewrite this. Of course, all that equals 0. E to the x, and I'm going to write it as x squared plus 2x minus 3. All this in here is factorable. You can rewrite it as, let's see, e to the x, x plus 3, x minus 1. And all that equals 0. All right. Hopefully you have a little basic knowledge of e to the x. All of us took algebra and pre-cal. Of course, we did pre-cal through a pandemic. So maybe your pre-cal might be a little weak when it comes to these. This e to the x is always positive, guys. Chavez, I don't understand. What do you mean? E to the x looks like this, guys. Notice e to the x is always above the x-axis. So the y values are always positive. The output of e to the x is always positive. So that means I have two x values, -3 and +1. Those are my critical points. If something happens, it's going to happen there. I draw my number line. I label this f prime. I go to 1 and I go to -3. I'm going to pick values. I do not care about e to the x. E to the x is always positive, like we said. I'm just going to choose values. If I choose -10, x plus 3 is negative, x minus 1 is negative. When I put a -10 in there, negative times a negative is a positive. If I put a 0, I could have put any number between -3 and 1. I decided to put a 0. If I put a 0, I get positive times a negative, which is a negative. And if I put a 5 or a 10, I get positive times a positive, which is a positive. So there we go. I have at -3, there's a sign change. So at -3, that is a, what is that? A max. At a -1, that is a min. And same situation as before, they are not absolute, so those are local, because this graph goes up forever and goes down forever. What's up? Yeah, which is negative. We're good, right? Okay. All right, guys. So there it is. That's your review. That was the first derivative test. We did call it first derivative test yesterday, didn't we, or no? Didn't at the very end, didn't it say like first derivative test? Okay, I'm gonna go back and look at my video and see if I said first derivative test. Let it be known that Viacana said that I did not say first derivative test. Hey, Ms. Delmer, you want to say hello to the kids in virtual? I mean, they can't. We can't see them, but they can hear us. Oh, because I'm doing these notes here.
Oh, hello.
That's
How's
Delmer,
it
guys.
going? Happy weekend.
Hi.
All right, let's see. What does it mean to be concave? Oh yeah, hook us up with some candy, Delmer. To be concave up or concave down. And what's an inflection point? All right, so yeah, you guys go. Don't worry. So here it is. Concave up, obviously, is this part right here. And concave down is this one. And you guys know that in case you need a better visual, this is concave up. This is concave down. You guys get candy? Okay. And a point of inflection or an inflection point is bam right there. Take a guess. Use context clues. What do you think inflection point means? For what switches? Perfect. That's it, guys. That's all it means. So write that down for your notes. Inflection point is just where concavity changes. Where concavity changes. Be very, well, okay, we haven't talked about the second derivative sign, so we're fine right now. Okay. Are you cold? I'm sorry, miss. Did you write this down already or no? Okay. All right. We're going to observe the behavior of f prime when f is concave up. So I'm going to draw a graph. I'm going to call this f. Notice that I'm labeling it or color coding it. Black is f. Cool? I want you guys to notice, I don't know what the value is because look, we don't have an equation. Like I didn't write like this is x squared plus 5. I just want you guys to notice f prime at that moment, is it a positive or negative value? Negative. F prime at this moment, it's a negative value, but notice that it's not as large. If the first one left to right was -8, this one's like a -5 or something like that. Look at this. There we know exactly what f prime is. It's 0. A steeper number, a bigger number than 0, and an even steeper number. Tell me what's happening to f prime, the behavior of f prime. F prime is, there's a word for it in math. No. Well, the f is quadratic. F prime is not quadratic. F prime is linear, if anything, if it's a parabola like this. There's a word for it, though. Look, tell me. I'm at -10, -5, 0, 2, 10. What's that word? F prime is increasing. As a matter of fact, I'm going to spell it screaming. That's increasing. Did I spell it correctly? If f prime is increasing, okay, before I continue, let's make sure that we understand what we're doing. The rate of change, notice the rate of change of f is increasing. That's the same thing as saying f prime is increasing. If f prime is increasing, that means, guys, focus here real quick because this is super important. That means f prime prime is what? Oh, man.
Positive?
Yes. Oh my God. You got it right on the first time. Good job, miss. If f prime is increasing, that means f prime prime is positive. It's the same way if we would have said if f is increasing, f prime is positive. Because if f is increasing, that means f is going up. So that means my slopes have to be positive. Positive slopes. It's the same logic. Does that make sense? No, okay. It depends. Yeah, well, if there's a parabola here, so the question was, is it positive and increasing? That actually means something. Positive and increasing means something very specific. We'll get to that when we get to it. Right now, all we need to know is this. F prime increasing means F prime prime is positive. Yes or no? Perfect. So what does that mean? It just means that the rate of change is some positive number. So now let's see what happens when we're concave down. This is F. It's obvious that it's concave down. I'm gonna do F prime in red here. So look at this tangent slope. It's a pretty steep slope. Not as steep. 0 there. It's going back to steep, but in the negative direction. What's happening on this one? F prime is decreasing. What does that mean about F prime prime? Perfect. Is what? Negative. Okay. Before I continue and write my conjecture about F prime prime, let's make sure we understand. Yes. If it's x squared, yeah. It will be a constant. Good job, miss. You're already putting all the pieces together. All right. I want to make a conjecture about F prime prime. So conjecture means like a statement or a fact. So can we say definitively, look, we have evidence right here. Can we say definitively that if F prime prime is positive, that this means that F is concave up? What do you think? Yeah, it will always make a concave up And in case you're wondering, why is it always going to make a concave up? Think about it, guys. The rate of change of the rate of change is increasing. Wait, did I say that right? The rate of change of the rate of change is positive, meaning that your rate of change is increasing. So think about it. You have increasing slopes. That's going to create this concavity because all that you're doing is this. The rate of change of the rate of change is increasing. See? Boom. If the rate of change of the rate of change is decreasing, but you're still going up, it's going to look like this. The rate of change of the rate of change is decreasing. It's getting more flat. So look what's happening. If it's creating this, that's concave up. If it's creating this situation, that's concave down. Does that make sense? Perfect. So now that we said that, can we make a conjecture about this one? About F? If F prime prime is negative, what does that mean about F? Concave down. Always, guys. Now, I don't want you to be a robot. It's very easy to be a robot and then just always tell me these statements as fact. Can you pass the AP exam being a robot? Yes, but it's not going to help anyone because you're just memorizing stuff. Try really hard to understand the concept because that's what's important. If you understand the concept, you'll be able to answer any question. Any question, guys. You okay, Viacana? So my conjecture, F prime prime being positive means two things. It means that F prime is increasing. And it means that F is what? Concave up. That's a up. That's a U. It just didn't come up. All right. F prime prime being negative. That means two things again. That means F prime is decreasing. And it means that F is concave, not concave up, concave down. So there it is, guys. Those are the statements. Is it easy to remember? Yeah, but I don't want you to be a robot. Make sure you understand the concepts. All right, here we go. Use the concavity test. That just means to take the derivative twice and see whether it's positive or negative to determine the concavity of the given functions on the given intervals. Okay, this is a parabola. Everyone knows that for a parabola, we better get concave up. Or for this one, it's a positive parabola. So the second derivative better be positive, and it is. Check it out. Y prime equals 2x. That's just the first derivative. Y prime prime equals 2. That's always bigger than 0, no matter what. So writing a statement, concave up on 3 to 10. By the way, for concavity, never put brackets. Put that somewhere on the notes. For the intervals, for concavity, never put brackets. Always parentheses. Oh, don't worry. Yeah, that's fine. Concave up on 3 to 10. Really concave up on the entire domain, but they asked specifically 3 to 10. Maybe that's a bad question. I might have to rewrite it for next year because that's a bad one. Obviously, it's concave up everywhere. This is also a bad one, I think. This is just sine x with a vertical shift of 3 up. If you guys know how sine x looks like, do you guys know how sine x looks like? Then you can already tell me, look, without calculus, here's how sine x looks like. 0, pi over 2, pi, 3 pi over 2, 2 pi. That plus 3, all it's doing is moving up this graph 3 up. Tell me, where am I concave down? From 0 to what? 0 to pi. Where are you concave up? Pi to 2 pi. That better be the answers we get. We just did that with just pre-calc, guys. That's all we did. We just did pre-calc. That plus 3 just moves it up 3. Let's see if we get these answers with calculus. See, so sometimes calculus just makes things complicated when we could have just drawn. But these are just examples just to show that it works. Y prime. What's the derivative of sine x? Cosine x. We don't need that one. We need the second derivative. Y prime prime. What's the derivative of cosine x? I get my critical numbers. I equal that to 0. Actually, you can't call them critical numbers if it's second derivative. But we're equaling it to 0 because something's happening there if there's a sign change. So x equals, where is sign 0 between 0 and 2 pi? It's 0 at 0, it's 0 at pi, it's 0 at 2 pi. And of course, we're not checking 2 pi and 0, so those are endpoints. I do my little number line. Notice that I put brackets on here. This is just to indicate that my interval, well, really, I can put parentheses to indicate that I stop at 0 and I stop at 2 pi. I'm going to put pi somewhere here. If I choose a number to the left of pi, like pi over 4, sine of pi over 4 is square root of 2 over 2. But I have a negative in the front, so there's going to be a negative. If I choose a number to the right of pi, like 5 pi over 4, to make it simple, or any of them, sine of 5 pi over 4 is negative square root of 2 over 2. Negative times a negative is a, and look, the math worked. Concave down, 0 to pi. That's a 0 over here, and here's 2 pi. Concave down, 0 to pi. And concave up, pi to 2 pi. How are we feeling, guys? We still feel pretty good? F, don't say it. Yeah, you said F prime prime, but you didn't say, you said it. When F prime prime is negative, it is concave down. Okay, you know what? You brought up a good point. Time out, guys, and this is gonna be something cruel. You might not agree with it. You know, there's some students that did not get the AP credit for concavity on the free response if they use the word it. Chavez, what are you talking about? If you say, you got to say it like this. So let's say they give you a graph. Let's say they give you G. Let's say they give you two graphs, G and F. And they tell you, I want to know where G is concave up. And they write, G prime prime is positive on this interval, which means it is concave up. Then they go, what is it? Because they gave you two graphs. They gave you G and they gave you F. You cannot just say it. Does that make sense, guys? So you got to be very specific. G prime prime is positive on this interval. Hence, G is concave up on this interval. So you got to be very specific with math. Do not avoid the words it. Every time I see the word it, I'm going to circle it. I'm going to count it wrong. It's for your benefit. Trust me. It may not be to your benefit grade-wise, but in the long run, it will be. Trust me. Don't worry, guys. I grade very, very generous. You guys already know that. All right. Let's look at this one. Relax. So they want us to look for all points of inflection on this graph, and you can already see where it's happening. It looks like it's right there, so it's that number. So it looks like you're gonna need a calculator here and right there because it looks symmetric. So it looks like it's concave. Concave down right there, and then it looks like it's concave up, and then concave down, and then concave up. We're gonna find that number. Obviously, they already found it for us. It's 0.707. Let's see if we can do this without a calculator. And then if we need to use the calculator, we'll use Desmos. You guys ready? So I want to find all points of inflection. What am I going to do? I need to find what? The second derivative, and then I need to see where the second derivative changes signs. So I'm going to equal the second derivative to 0. That you don't always do that, but for now we are. So here we go. Y prime equals, the derivative of that is, let's see, e to the negative x squared times the derivative of negative x squared, so negative 2x. Notice that hopefully we're becoming a little more experienced. I left some room after the equal sign so I could write that negative 2x in there. If you did it, no big deal. Just go ahead and fix it at negative 2x e to the negative x squared. So now that I'm here, I want to take another derivative. Well, I got to do what rule now? Product. You have to. You have no other choice. So first, times derivative of the second. The derivative of e to the negative x squared is what we just got there. Negative 2x e to the negative x squared. Plus second times derivative of the first. So get up to there. I'm going to fix it, and I'm going to equal it to 0. Y prime prime equals negative times the negative is a positive. 4x squared e to the negative x squared minus 2 e to the negative x squared. I see that I can factor out an e to the negative x squared. Again, I'm going to set that equal to 0 to find points of inflections. To find points of inflection. So e to the negative x squared. So I'm going to have 4x squared. You know what? I can factor out a 2 as well. Let's factor out that 2 e to the negative x squared. So I'm going to have 2x squared minus 1. So we don't care about this. That will never equal 0. Never. The limit will, but in itself it will not. Never equal 0. If I put the word limit in the front, it will, but right now we don't have limits. This will, yeah, e to the negative x squared will never touch the x-axis. You'll get really close to it. So if I were to write the word limit, like you'll get really close to it, but you'll never touch the x-axis. We can look at it in Desmos in a little bit if you want to. So here we go, guys. I'm solving for this. 2x squared minus 1 equals 0. 2x squared equals 1. Divide by 2, x squared equals a half. And then square root, x equals plus minus 1 over square root of 2, which simplifies to plus minus square root of 2 over 2. Oh, we should have recognized that. 0.707, yeah, that looks familiar. That is square root of 2 over 2, guys. Don't believe me? Type it in your calculator. You guys don't believe me? Oh, do you guys remember? Does it look familiar? And there it is. And sure enough, yeah, they found one of them for me, that 0.707, that's that plus 1. So it said find all. So I'm going to write a quick statement that I found them. I'm going to say x equals, and I guess we'll show both of them right here. Square root of 2 over 2 will give, or r, right? X equals plus minus square root of 2 over 2 are the points, are the x coordinates where the points of inflection occur. I didn't give this graph a name, I just called it y. If I would have called it f of x, I would have said where these points occur, points of inflection occur on the graph of f. But since it just says y equals, I just left it like that. Does all this make sense, guys? All right, I'm happy. Oh, yes, yes, finally. We'll stop after this one because, yeah, we'll stop after this one right here. Because this one might take a while. And it's cold. I don't feel cold. That's because every time I talk math, I'm like, yeah. Okay, I'll stop. I get really hyper, like the more math we do. All right, I'll stop. Let's just do this. All right, example 4. The graph of the derivative of function f on the interval -4 to 4 is shown to the right. Stop right there. What am I looking at that graph? F prime. Label it, label it, label it. This is f prime. Answer the following questions about f, justifying each answer with information obtained from the graph of f prime. Okay, I think we're ready, guys. Are you guys ready? No, don't be scared. Let's see if we understand the concept. What intervals is f increasing? Left to right, when you read a graph, left to right, where is f going up? From -4 all the way to where? Past 0. From -4 to 1, why? Because what's positive? Perfect. Now, if some of you might have said, okay, so I'm going to say this first. F prime is positive on, so where is F prime positive? -4 to -2. And -2 to 1. Now f prime is positive. This is f, right? This is f prime. Now that's where f prime is positive. Where am I increasing? And good job, Viacana, with utilizing that fact. Oh, this is f prime, right? This is the graph of f prime. Am I above the x-axis? So if I'm above the x-axis, the f prime values are positive. Now f prime is decreasing, but f prime is positive. Does that make sense? Or no? Correct. Yeah. F prime. Let's not get ahead of ourselves. I'm above the x-axis. This is f prime, so f prime is positive. If f prime is positive, sorry, what? Yeah, this I'm above this line. Everything above this line, the y values are positive. But these are not y values, these are f prime values. Does that make sense? Okay. Don't. So here we go, guys. So where is f increasing? I'm going to say it like this. F is increasing on -4. Tiff told me that she wants to use parentheses all the time. So I'm going to use parentheses. -4 all the way to 1. There it is. We're good? Guys, are we all good right now?
Yes.
Okay. Why did this laptop disconnect? Or was it never? It was, no, I connected it. I know I did. Sorry, guys. I'm having some technical, no. Okay. Here we go. What intervals is the graph of f concave up? So look at your notes. When is f concave up? Perfect. F, I'm just writing this. This is just for your notes. F is concave up when f prime is increasing. This is f prime. All right, where is f prime increasing? Yeah, -2 to 0. I think they meant to put the 0 there. And then 3 to 4. So I'm going to write f prime. I'm going to write f first. F is concave up on interval -2 to 0. And you can also write the word union there. 3 to 4, since f prime is increasing on those specific intervals. There we go. Language is concise and clear. Full credit. If you would have mentioned f prime prime, you could have. But instead of saying f prime prime is increasing, you would have to said what? F prime prime is positive. Which one's the better answer? Because we have the graph of f prime, this is a better answer. No, both will be counted right because you're stating facts. Are we still okay, guys? All right. At which x coordinate does f have a local extrema? Where do I have local max mins? -2, is -2 a max or a min or neither? F prime is 0, but is there a sign change on f prime? So a -2, it's neither. So you don't have a max or a min. No, 3 is neither either. F prime is negative there. F prime is negative at 3. 1 is one of them. F prime is changing from positive to negative at 1. What graph is this? F prime. So wherever you cross the x-axis, you're changing signs. F prime is positive above the x-axis. F prime is negative below the x-axis. No? No. 1 is 1 and the endpoints are another. They told me I'm in a closed interval. So, no, of course not, but it's an endpoint. Yeah, it is. We talked about it yesterday in the notes. As a matter of fact, we had specific notes where we said, what if we started an endpoint and the derivative is positive? If we started an endpoint and the derivative is positive, that's a min. If we started an endpoint and the derivative is negative, that's a max. Okay, I'll start again. Where does F have local extrema? I don't think anyone can deny the fact that x equals 1 is for sure a local extreme. The derivative is changing from positive to negative, F prime. So that is a what? Local. The derivative, F prime, is changing from positive to negative. Local max. Local max, since F prime changes sign from positive to negative. From positive to negative at x equals 1. Okay, and then I went ahead and told you that x equals negative 4 is another, and a lot of you guys were looking at me confused. Well, the ones that are here looked at me like, what? Or negative 4. Negative, and also 4 as well, but we'll tell you why. So if we were to go to the notes from last time, and hold on, don't worry guys, I'm gonna make it quick. Was it note 17? Yes. Open. So here's note 17 from yesterday. And let's go to the endpoints right here. So here it is. It says at a left endpoint, if my derivative is negative, I have something that looks like that. And that would have been a max. Look at number 2. It says if my derivative is positive from a left endpoint, then I have a min, because that's how the graph of F would look like. Does that make sense? That's F. The line drawn is F. The line drawn is F. That makes sense, guys? So, coming back, x equals negative 4. At negative 4, my derivative is immediately positive. So I have an endpoint, and immediately to the right, my derivative is, so my f is going up. It's a min. Local min. And then at x equals 4, so let's think about what's happening for f on x equals 4. So let's start at 3. Ready? F is going down. Why is that going down? Because f prime is negative. Do you guys see that? Going down, 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 boom. Practically a horizontal tangent at 4, but it's an endpoint. So if I've been going down all this time, that is a local min. Because I've been going, remember, read a graph left to right. We've been going down all this time. Does that make sense, virtual class? Yes.
Can you repeat that again?
Yes. The graph of f has been decreasing, has been going down from 1 all the way to 4. If I have something that's just been going down from 1 to 4, here's 1, here's 4. I've just been going down. Boom. It's going to be a min. Because I've just been going down this whole time. All these values are negative. Remember, this graph is f prime. If f prime is negative, that means f is decreasing. Negative 4 is an endpoint. Yeah, that's where I stop. That's where f stops. So the graph of f between 1 and 4 is decreasing. So imagine a curve. Which one? Negative 4? Okay, so -4 is an endpoint, and immediately to the right of -4, F goes up. Because F prime is positive. Does that make sense? All right, here we go, guys. Did we use up that minute to process?
Would -4 and 4 also be absolute or no?
Absolute min. Let's see. Go up, 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 up. That's hard to tell because of I can't tell if these areas here are bigger than this area. So maybe it could be absolute, but I would not say. I hope I didn't ask that question. Did I ask that question? Good. Yeah, good thing I just said the word local. It's hard to tell because the area under the curve is what tells us how much we have gone up. And I probably shouldn't be telling you that. And then this area under the curve tells us how much I go down. And I probably shouldn't be telling you that either because we haven't mastered concepts and I don't want you to be robots. So it's hard to tell just by looking at this graph. It has to be very concrete for us to know definitively. Are we okay, Mazuka?
I think so, yes.
Okay. Letter D. What are the x coordinates of all inflection points on the graph of F? We know how to do this one. X1 is not one of them. No, yeah, we do. Guys, all right. Inflection points happen when the concavity changes. So if I have a graph, if I have the F prime prime graph, I'm looking where I cross the x-axis. Do I have an F prime prime graph? No. What graph do I have? F prime. So now let's look at our notes. Since I have an F prime graph, look what we did. F prime prime is positive if F prime is increasing. F prime prime is negative if F prime is decreasing. So I'm going to look to see where what happens when I change from what to what. No, not negative to positive. That's if I have F prime prime. I have F prime when I change from increasing to decreasing or vice versa. Does that make sense? Because I'm looking for points of inflection on F. F is concave up, F is concave down. Wherever I change, those are points of inflection. So let's go back. So look, this is F prime. I am decreasing. F prime is decreasing until I hit what? -2. X equals -2 is an answer, comma. And now I'm increasing until 0. It looks like it's 0. It looks a little bit to the left of 0, but let's pretend it's 0, comma. And then I decrease again until I hit what? 3. And then that's it. And I'm going to say why. Since these are the x coordinates where F prime changes, let's see, what happened first? Decreasing to increasing? Changes from decreasing to increasing and vice versa. If this were the graph of F, the point of inflection would be a -1. But this is a graph of F prime. Okay. And don't worry, we're going to make it simple. Ready, Tiff? All right. When it says sketch a possible graph for F, everyone has a hard time all the time until I tell them one little thing. There's only 4 scenarios you can have. Only, and that's it. What are those 4 scenarios? Let's talk about them. So don't write this down. Just listen. Don't write this down. 4 scenarios. Let's make F increasing. The only 2 scenarios that happen when F is increasing is either F is increasing concave up or F is increasing concave down. That's it. Those are the only 2 scenarios if F is increasing. There's 4 total because if F is decreasing. But that's it, right? So if F is increasing, I can either look like this, increasing concave up, or increasing concave down. Does everyone see that? All right. Now, what about if F is decreasing? I got another 2 scenarios. If F is decreasing, I either have F is decreasing concave up or F is decreasing concave down. So let's see how that looks. Here's decreasing concave up. There it is. And here's decreasing concave down. Do we see how we did, how those are the only 4 scenarios? Now, if it's increasing with no concavity, that's just a linear line. Are we okay? All right. I'm going to erase these. And now we're going to go step by step on this graph. So let's see. I'm going to color code it. Check it out. This in blue, F prime is positive, but F prime is decreasing. Do you guys see that? If F prime is positive, that means F is increasing, but because F prime is decreasing, yeah, guys, this is a play on words. You got to be very careful or you're going to get confused. F is increasing because F prime is positive. Everyone agree? Left to right, I'm going to be drawing a graph going up. But F prime is decreasing, which means F better be concave down. So we're going to draw increasing concave down from -4 to what? -2. Who cares about the Y values? Here we go. All I care about is X values, guys. Oh, let me make that in black and I'm going to color code it. Here's -4. I'm going to say here's -2. And I put this in blue. So let me write it in blue. Nah, I can start wherever I want. So I'm going to start it. Where do you want me to start it? Above the x-axis? Because they don't give me an initial condition. Okay, I'm going to start at that point right there, guys. And I'm increasing and concave what? Concave down. So here it is. Increasing concave down. Stop right there. That's increasing concave down. It looks like at -2, I have a horizontal tangent. So I made it look like at -2, I'm going more horizontal. See, I have a little horizontal tangent right there. All right, let me color code it. From -2 to 0, I'm still increasing, but I'm concave what? Up. I'm still increasing, but concave up. So I'm going to say 0 is right here somewhere. Increasing, but concave up. And there it is. That little part in green is definitely increasing concave up. All right, I'm going to continue to color code it. Do you guys like these color codings? I'm going to use red now. And I'm just going to do a little section here. From 0 to 1, I'm concave down because F prime is decreasing, but F is increasing. So increasing concave down. Cool? And at 1, okay. No. F prime is decreasing, so F is concave down. I'll replay the video to make sure what I said, but pretty sure I said F is concave down. F is concave down from 0 all the way to 3. And at 1, I have a horizontal tangent, which is fine. Look, from 0 to 1, increasing concave down. I'm going to say 1's right here. Increasing concave down, guys. At 1 horizontal tangent, yeah, I look like I have a horizontal tangent there. Yes, the slopes are positive. And now here we are back in, what color should I have? What color have I not used? I've used all of them. I'm going to use black, guys. I'm going to use black. Black for the last part. Oh, yeah. Say it again. Between 1 and 3, you are concave down. F is concave down because F prime is decreasing. And F is moving downward because F prime is negative. So decreasing, concave down. That's easy to do. Here it is. I'm going to say here is 3. Increasing, concave down. Increasing, concave down. Perfect. That looks beautiful. Point. Why did I put a point at 3? Because I'm going to be changing concavities. So here it is back in red. Decreasing, concave up. When you hit 4, you want to have a horizontal tangent because it looks like it hits the x-axis. We're not looking for perfection. So here we go, concave up. When you hit 4, I'm going to say 4 is right here. Concave up. Boom, beautiful. There it is. Where did I confuse you? Three to 4. That's right. So F is decreasing. Okay. Yes. Yeah, but not because F prime was negative, but because F prime was what? No. F prime is increasing. Let's look at the F prime graph. Are you looking at the F prime graph? Between 3 and 4, F prime is increasing. It's going up. F prime. F prime. Yeah, I know. It's play on words. Because F prime is increasing, F has to be concave up. The rate of change of the rate of change is increasing. Or it's positive. That's what you told me back here. Remember? Look, right here. You told me if F prime prime, if F prime is increasing, F is concave up. That means that F prime prime, the rate of change of the rate of change is positive. That's what's happening right here in this red from 3 to 4. That looks like F prime is increasing to me. If F prime is increasing, F is concave up. And well, look, here's F, 3 to 4. And look, sure enough, my rate of change of the rate of change definitely looks positive because the slopes are increasing. The slopes are increasing. At 3, there was some negative number. At 4, it's 0. That means my slopes are increasing. -5 to -2 to 0. And look, it's concave up. Do you see that? Okay. All right, guys, let's come back.